Let's take a look on this problem. For this problem, you can use the manual method or you can use the reference method. In this video, I want to show you how to use the reference method. First of all, let's take a look on the reference to see the more similar diagram to this one. So let's open the reference. You can go to Canvas, reference, and open the shear and moment deflection diagram reference over here. Let's see. So we have figure 5 is very similar to the one we have in the problem. So let's use the information over here. First of all, let's draw the load diagram first. The load diagram is just exactly the same thing. And this one is 860 pound over feet. And the length of this one is 13 feet. And I will know here this one is low. Next one is shear. And then we have moment. I will put the unit over here. This one is pound. This one is pound. This one is pound. Foot. Then we don't have to know for the unit. Alright, so now let's draw the shear diagram. Let's check the reference. We will have the shear diagram will look like this. So I will mimic and draw a similar thing like that over here. And then over here I have V1. V1 is over here, we equal to W divided by 3. And I know W is the last W is equal to a half multiplied by small w. Small w is the one over here. Multiplied by L. L is the length over here. Right? Alright, so I know that. First, let's calculate W first. So we have that W will equal to 1/2 of small w multiplied by L will equal to 1/2 multiplied with small w is 860 pound foot multiplied by L is 13 feet. And then feet and feet cancel. This one will equal to 2680 pound. And then we have V1 will equal to the W we just calculated divided by 3. So the one over here we have V1 will equal to W divided by 3. This one will equal to 2580 pound. Now let's check back to the reference. This value over here is V2 and V2 will equal to 2/3 of the W. So I will have this one is 2W divided by 3. I will have that equal to 3727, and this one is pound. Alright, so now we done the shear diagram. Now let's move with the moment diagram. For the moment diagram, the shape of that is, it will look like this. So I can draw it over here like that. And then we have the, let me clean here a little bit. And then we have the M max. M max will equal to this one, 0.1283 large W multiplied by L. So this one will equal to 0.1283 large W multiplied by L. This will equal to 93.24. And the unit of this one is pound foot. If you write pound foot there here, then you don't have to put the unit over here. Next one, let's discuss about what is the Vmax and Mmax in this case, and where are they. So over here we can see obviously the Vmax is this one. Vmax is 37.27 pound. So we have Vmax equal to 37.27 pound. And the location of that is 13 feet from the left. If you just draw, consider this one is 0, and you draw all the way here. So this one is at 13, right? Maybe I'll just write at 13 feet from, maybe just like that, it will understand easily, at 13 feet. And then I have M max, we equal to, M max will equal to this one, right? 93.24 pound foot. And at, if we want to know where is the location of M max, we need to check the reference. So you can see from the reference, it say this one is 0.57741 from the left, from this one. So if we go back here, so we have from here to here, we equal to 0.57741 of the value L. So we need to multiply by L. L is 13 feet. 13 feet. This one will equal to 7.5 feet. So this one, the M max will at 7.5 feet. Okay. So now let's check C. C, what is the shear force at 5 feet from the left? 5 feet from the left. Now we need to check the reference again. So we can see that the question is for the shear force at 5 feet from the left, that is Vx. Okay, Vx at 5 feet over here. So we just use this formula, and then we will replace x with 5 feet. Okay, so we can go back here. We will have C. The formula of that is large W divide by 3 and subtract 2 large W x square divide by L square, and we just plug in W will be 2680. 2680 divided by 3. Subtract to 2680. Multiply by 5 feet is 5 square. Divide by L is 13 square. And now we're gonna have that equal to 496.9. I will just round up 497 pounds. So you know that. Maybe let me clean this one a little bit. 5 feet from here to here. If we have 5 feet here, the value of that, no, the value of that from here to here is 496 pounds. Right? All right, now let's check question D. What is the bending moment at 11 feet from the left? For this one, we just apply the formula mx over here, and we need to find that at 11 feet. So we just plug in 11 into the x value over here. The other thing, we already know that, so just plug in all of that over here and then calculate this one for me. This one I want you to try it by yourself for question D.